Okay, so hopefully my fan's not too loud, but we're going to go over a physics problem. You might have heard the amber and fur being talked about before. The reason why this is such an important physics problem is because, let me turn my fan down. It was loud for me, so I'm assuming it's loud for you guys too. Back when electricity and magnetism were kind of their own things, we learned a lot about electricity and kind of the foundation from it by taking amber and fur. Both are neutral, and then you rub them together and electrons are transferred. And then all of a sudden, if you look at this picture, there's 1, 2, 3 negative charges, 3 positive, and then the same for the fur. But when you rub them together, you have an excess. So here you have 1, 2, 3, 4, 5 negative charges to only 3 positive. It has a net negative charge. Where did those electrons come from? Those negative charges came from the fur. And because they're losing electrons, now they're positively charged. So we're going to look at an example where, let's say, so they're both neutral. And then what we'll say is the charge transferred between them is 800 nanocoulombs. So what that means is they're both neutral, and then one of them gets plus 800 nanocoulombs. The negative will get minus 800 nanocoulombs for the charge. And if we were to separate these, so if you were to take the negatively charged part and the positive charged part, let's say we separated them by a distance of 20 centimeters, we want to know the force. Well, again, and this is a big equation in this class, the force between two charges is K constant, absolute value of Q1 times Q2, all divided by the distance between them squared. And we broke this down a little bit in the last video. K is a constant, Q is our charges, R is the distance between them. So the force is going to be what? Well, we'll start with K, our constant. We said that's about 9.0 times 10 to the 9th newtons times meters squared over coulombs squared times the absolute value of, those are nanocoulombs, so that's times 10 to the negative 9th coulombs times negative 800 times 10 to the negative 9th coulombs, absolute value, divided by the distance between them. So 20 centimeters is 0.20 meters squared. So we plug all these numbers in, which I've already done, and you should get 0.144 newtons. Now, how should we draw our force vectors here? Over here and here. Well, the charges are opposite, meaning this one has a negative charge, this one has a positive charge, so they're going to attract each other. So these are the forces. Okay? And that's because the charges are separate. And more or less, that's all we're looking at. So we talked about the charges, whether they're attractive or not attractive. We figured out how to solve it. The big thing that might be a little confusing is just knowing right here, they both have a net charge of 0. Here you mix them together. And then after you do that, there's a transfer of electrons, and now they're no longer neutral. So if you give this amber excess electrons, so as now a charge of negative 800, then the fur has to have a charge of plus 800 times 10 to the negative 9 coulombs, because the electrons are coming from the fur. So now you're giving the electrons away, so you have an excess of positive charges. So that's how we know the two charges. That's really the only part that I think might confuse some people. But other than that, it's a pretty straightforward problem. So hopefully all that makes sense.